All right. These are the answers to the test 1 in class review for 1324. Make sure you also do the review that's on my webpage for 1324 test 1. I'm just going to read through this with you. It says, Joshua conducted a survey of 135 summer school students as to what they did last night. It was found that 38% went to the movies, 43 to the chicken, and 63 stayed home. So if you're given a bunch of stuff where it says how many people did what, you want to draw a picture. So that's why I started off over here drawing this Venn diagram. Okay, I made one circle to represent that they went to the movies and one circle to represent they went to the chicken. And it said 43 went to the chicken, can't do that. The whole thing was 135. This whole thing is equal to 135. 38 went to the movies, can't do that. The whole movie circle should add up to that. 43 chicken, the whole thing should add up to that. But right here where it says 63 stayed home, I know that number goes on the outside. So if I do 135 minus 63, that tells me that 72 students went to either the movies or the chicken or both. So I can then move over here to my formula. So at this point, all I have is this number 63 outside. But if I move to my formula, the number who went to the movies or chicken or both was 72. And that equals the number who went to the movies, it told me that, was 38. The number who went to the chicken, it told me that one, minus the number who went to both. Subtracting those over, I get negative 9 equals negative the number in the intersection, so 9 will go right there in the middle. But the question says how many students went only to the chicken. So I go back, 43 went to the chicken, so 43 minus those 9 give me 34 students who went only to the chicken and nothing else. E and F are two events of an experiment the same sample space. Definitely go straight to drawing your Venn diagram. It says suppose E intersect F complement is 0.25. That means it's not in circle E, or it is in circle E, so we've narrowed it down to circle E, and it's not in F, so it's just right here. So that's where I put the 0.25. It's in E but not F. This one says it's in E and F, so that's right in the middle, 0.34. The probability of circle F is 0.48. If I already have 0.34 in there, I could do 0.48 minus 0.34 and get that there's 0.14 on the outside over here. And since the whole thing adds up to 1, I can do 1 minus all those numbers, and I get 0.27 on the outside. And then the question says, find the probability of F union E complement. Union means plus, so I want to add up everything in F plus everything not in E. I already got the 0.14, I need to include the 0.27, and that comes out to 0.75. An experiment consists of flipping a fair coin and choosing a gummy bear from a bag containing red, purple, and green gummy bears. Heads or tails from the coin is recorded as well as the color of the gummy bear. What is an appropriate sample space for this experiment? A sample space is the set of all possible outcomes. And so I write my S equals the set containing. So I'll go through the scenario of the coin could land on heads, and I could get red gummy bear. So heads red, heads purple gummy bear, heads green, or it could land on tails. So tails red, tails purple, tails green. Those are all possible outcomes of this experiment. In New York, there is no limit to the number of times one can take the bar exam. A group of New York lawyers was surveyed. Let the random variable X denote the number of times the lawyer took the bar exams until he or she passed. How many times can one expect to take the test before they pass? So I'm going to put my X values in list 1. So here's my calculator. Okay, I'm going to make it smaller actually. And I'm going to put in, can't find where to go. Okay, I'll put my X values in list 1. So I'm going to go to stat, over to stat edit. I already have stuff in there, so I'm going to arrow up and hit clear and come down. Arrow up and hit clear and come down. And I'll put my X values in list 1. I get to 1, 2, 3, 4, 5, 6, 7. And then I'll put the number of lawyers in list 2. Once I have them all in there, I'll hit second quit. I'm going to go back to stat, over to calculate, 1-bar stats. If you had the old school calculator, you have to type in L1, comma L2 before you hit enter. This is the new school. And the very top one is X bar. That's the expected number, or the average. So we could expect them to have to take it 2.934 times before they pass it. A drawer contains 5 blue, 8 red, 4 white, and 7 black buttons. It says Cooper's making a snowman and needs 4 black buttons. So he needs 4 black buttons for the mouth. So he starts pulling buttons out of the drawer one at a time and doesn't stop until he has the 4 black buttons. Let X denote the random variable. Let X be the random variable denoting the number of buttons he pulls out. So he's not going to stop until he gets 4. So at the very least, he's going to have to pull out 4. That's the best case scenario. That means he pulled out 4 black ones straight at the beginning. So maybe it took him 5 times before he got 4 black, maybe 6 draws, maybe 7 draws before he got 4 black. So we need to think of the worst case scenario. The worst case scenario is he pulls out all of the blue, red, and white ones and doesn't get a single black one yet. So that adds up to 17. But if he pulls out all 17 of the blue, red, and white, we're guaranteed the 18th one will be black, the 19th will be black, the 20th will be black, and the 21st will be black, because that's all that's left in there. And that would give us 4 black. So it goes all the way up to 21. If the odds in favor of the Bulldogs winning this weekend are 5 to 9, so favor, whatever the word is, goes with the first number. So that's the favor, that's against. What is the probability they lose? So we're looking for the probability against. That's going to be the odd against divided by both odds. So the odd against was 9, divided by 5 plus 9 is 14. So we get 9/14 or 0.6429 as our probability. A survey of 84 roller derby women revealed that 32 of them had broken or lost a tooth while playing. 48 had broken bones. So I'm going to just go ahead and start drawing Venn diagram on this one. Okay, all together there's going to be 84. And 32 will be adding up for the lost a tooth or broke a tooth circle. 48, that's what the broken bone circle will add up to. 14 had never broken a bone or lost a tooth, so 14 will go on the outside here. That also tells us that 84 total minus the 14 gives us 70 had either lost a tooth, broken a bone, or both. So when we get stuck on our picture, we have to go to our formula. So the number who broke a tooth or broke a bone or both would be 70. And that equals the number who broke or lost a tooth, which it told us was 32, plus the number who broke a bone, which told us 48, minus the number who did both, which we don't know yet. If I subtract these two numbers over, 70 minus those, I get negative 10 equals negative the number who lost a tooth and broke a bone. So 10 will go right in the middle. But it's asking how many of the students or how many of the women surveyed had broken a bone but not broken or lost a tooth. So we're looking for these right here. So I've got to go back to 48 of them had broken bones. Subtract the 10 that I already have in the middle, and that leaves us with 38 had only broken bones. Number 8, a single 9-sided die is rolled one time. So here's our sample space, 1 through 9. What is the probability, I know that's a number, that an even number was rolled given, so it's not going to be out of 9, it's going to be out of what we're given. Given the number rolled was greater than 5. So out of these 4, so that's my bottom number, out of those 4, what's the probability an even number was rolled? Well, it happens 2 times out of 4, which reduces to 1/2. Then it says, what is the event? That's a subset. So I'll say E equals the set containing. The number rolled was an odd number less than 7. So back up here is an odd number less than 7. So here's 7. There's odd, there's odd, there's odd. So there's only 3 things in that event or subset. 2 fair 6-sided dice are cast. You won't have a dice chart right beside it, but you could go to the front page of your test and find one. It says one is blue, one is black, so I labeled one's blue, one's black. What is the probability, so I'm looking for a single number between 0 and 1 inclusive, that the blue die rolled an even number if it is known? That tells us it's not out of 36, it's out of what we know. It's known that the sum of the 2 dice was greater than 8. So I can come in here and draw a line and say, okay, greater than 8 happens right there. There's 10 of them. So instead of out of 36, it's going to be out of these 10. Out of these 10, we're looking for the probability that the blue dice rolled an even number. So here's my blue die. So that happens 1, 2, 3, 4, 5, 6. 6 times out of 10, which reduces to 3/5. The next one, though, says 2 fair 6-sided dice are cast, so look at your dice chart. What is the event? That's a subset. That at least 1 die rolled a 4, and the sum of the dice is 10. So at least 1 die rolled a 4 happened all along here, but it says and, so in addition to that, the sum is 10. That only happens 1, 2 times. So those will be the only 2 outcomes that are in this event. A game consists of randomly drawing 1 card from a deck of 52. If it is an ace, you win $25. If it's a face card, you win $10. Otherwise, you lose. It costs $8 to play the game. Let X denote your net winnings. That's how much you win minus what you paid to play. And then if you don't know, there's 12 face cards and 4 aces in a deck of 52. So the best case scenario is you get an ace. There's 4 aces out of 52, so the probability of that happening is 4 out of 52. And if that happens, then your net winnings is your $25 minus the $8 you paid to play. So 25 minus 8 is 17. So 17 is our first X value. If it's a face card, you win $10. But since you paid 8, you really win $2. And there's 12 face cards out of 52. It says for everything else you lose, so we'll lose $8, and we're missing this one. So right now these 2 add up to 16 out of 52. So if I do 52 minus 16, that means there's 36 cards left unaccounted for. So the probability I don't get an ace or a face card is going to be 36 out of 52. So it says, what is the probability distribution? This is my answer. It is a table of numbers. Find the expected value of X and explain what it means. So we could do this by hand if we wanted to. We could say 17 with a probability of 4 over 52 plus 2 with a probability of 12 over 52 minus 8 with a probability of 36 over 52, and we'll get this answer. Or we could do the same thing that we did up on problem number 4. We could put these in L1 and these in L2 and do our 1 bar stat, and this will be our X bar. If you need to remember how to do that, go back and watch problem number 4. And your average comes out to negative 3.7692. So what that means is over time, you could expect to lose, because it's a negative number, an average of, so this is an average. You're not literally going to lose $3.77. You're going to lose an average of that much for each time you play the game. So you don't expect to lose just that much. You expect to lose that much for every single time you play the game. All right, so here we have our contingency chart. It says the table above shows data from a survey that was conducted among baseball fans in California concerning how they watch baseball games from home. If a randomly selected person from this group is chosen, answer the 4 questions. So the first one says, what is the probability they are an Angels fan? So there are a total of 35 Angels fans out of 158. So that's how we get that one. The next one says, what is the probability they are an athletics fan who watches the game on Dish? So athletics fan, but specifically the ones who watch it on Dish. So there's 19 of those out of 158. So that's how we get this, 19 out of 158. Number 13, what is the probability just did that one. 14, what is the probability they don't watch the game given? All right, so we're given something, so it's not going to be out of 158. It'll be out of what we're given. We are given that they are a Dodgers fan. So out of these 29 Dodgers fans, we're looking for the probability they won't watch the game. So out of these Dodgers fans, that happens 5 times, 5 out of 29. And finally, what is the probability they are a Padres or Giants fan given? So we're given they watch the games on cable. So watch the games on cable, there's a total of 44. That'll be our bottom number. And it says, what's the probability they are Padres or Giants fan if they do that? So Padres right there, Giants right there. So that adds up to 29 out of the 44. That would be our probability for that one. All right. Kevin and Leslie went to a football game. I'm going to start a new one over here so you can see which numbers go first on this. Boom, boom, boom. Nachos, a hot dog, and Coke. The numbers given were 35 and 21. So it says 80 bought nachos. Wait, first it says 250 were surveyed, so this whole thing is going to equal 250. 80 bought nachos. That's the whole circle. We can't do that yet. 135 bought a Coke, so we've narrowed it down to these four right here, but not nachos, so we've just narrowed it down to those 2. 118 bought a Coke, so we've narrowed it down to these 4, and a hot dog, so we narrowed it down to these 2. These 2 spaces bought a Coke and a hot dog, so I can do 118 minus 35, and I'll get the 83. 89 bought nachos or a Coke, but not a hot dog. So these 3 will add up to that. 38 did not buy a Coke. So completely take your thumb, cover up the Coke circle. This is or a hot dog. So cover up the Coke plus the hot dog circle. Completely cover them up. All you have left is the 21 on the outside and the nachos only. And that needs to add up to 38. So 38 minus the 21 gives us 17. Back at the top, 80 bought nachos, can't do it yet. 135 bought a Coke, so they're in the Coke circle, but not nachos. So that's just these 2 areas. So we have 83 already. If we do 135 minus 83, we'll get 52 right there. Okay. 89 bought nachos or a Coke, but not a hot dog. So we're looking at these 3 spots, nachos or a Coke or both, but not a hot dog. And so I can do 89 minus those 2 numbers, and that will leave me with 20 right there. And then back to the 80 bought nachos, the nacho circle should add up to 80. Right now I could do 80 minus all those numbers, and I'll get 8. And then the missing number are those who bought hot dogs only. So 250 minus all these numbers gives me 14 that bought hot dogs only. All right, a group of people were asked which of the three stooges they liked best. The results are shown in the pie chart. If someone is randomly chosen from this group, what are the odds against? So odds are always two integers. Odds against would be the probability against divided by the probability in favor of them liking Curly the best. So Curly's over here, it's kind of hard to see, but it's 57% liked Curly the best. So the probability in favor of Curly, 0.57. Probability against is 1 minus that. And so how do you get from that to integers? Well, I would type it in 0.43 divided by 0.57, and that did not work. So 0.43 divided by 0.57, enter, and then math bracket puts it back in reduced form, so it didn't really get any smaller. So 43 over 57. Just make sure you don't put 0.43 because these need to be reduced integer ratios. You could have also put 43 to 57 if you wanted to. So number 18, we're given a universal set. A equals the set of all x such that x is an odd integer. So if I wanted to write A in a more friendly way over here, that's 135. And then it gives us subsets B, C, D. First one, it says A is a subset of A. That means everything that's in A is in A. That's true. B complement, so I gotta come over here and find B complement. That's everything in the universe that's not 0, 1, 2, 3. So that'd be 4, 5, 6. And then intersect that with D complement. So D complement is everything in the universe that is not 0, 6. So that would be 1, 2, 3, 4, 5. And then my sign is and. So I'm looking for what do they have in common. They both have a 4, they both have a 5. So they are the set containing 4 and 5. So this statement, set containing just 4, is false. C unioned with D complement. So I want everything in C plus everything in D complement without repeating. So I want 4, 5, 6, 1, 2, 3. Are those equal? Yes. So that is true. The empty set is a proper subset of A intersect B intersect C. So we know the empty set is a subset of everything, but it's a proper subset of everything except itself. So what we need to do is find out, is that empty or not? That will determine our answer. So A intersect B. A is 1, 3, 5, and B is 0, 1, 2, 3. So they both have a 1 and a 3, if we're just looking at that part, 1 and 3. But now we need to intersect that with C. So 1, 3 versus 4, 5, 6, they have nothing in common. So it's empty. And so the empty set is not a proper subset of itself. That would be false. This says if we take D and intersect it with not D. Think of a Venn diagram here. Here's D, okay? If D had the number 1 and out here had the number 2, we're looking at 1 and not in D is 2. What do they have in common? Nothing. So that would equal the empty set, not the universal set. Number 19, Dr. Pogue asked her class of math students to always bring 2 things to class, graphing calculator and course notes. One summer in a class, 31 students, so this whole thing would be 31. Got graphing calculator, got course notes. Says, the results showed 2 did not bring either, so that 2 goes on the outside. 23 brought the course notes. That adds up to 23, can't do it yet. 14 brought both, so I'll put my 14 right there. Then I can back up. If 23 brought the course notes and I already have 14 in there, then 23 minus 14 tells me 9 is right there. And if all of that adds up to 31, then I can do 31 minus these numbers and get 6. So it says how many brought their graphing calculators. So here's my graphing calculator circle. It adds up to 20. How many brought 1? of these two things. So graphing calculator only or course notes only, which would be 6 plus 9, which is 15. All right. Shading the Venn diagrams below. Definitely number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In case you can't see my numbers, I'll write them in red. So my main operation is union. That means plus. A union B is everything in A plus everything in B without repeating. So I wrote 1, 2, 3, 4, 5, 6. Plus C complement is everything not in C. So that'd be 1, 2, 3, 8. So I wrote those. And then the plus means shade both. So I'm shading 1, 2, 3, 4, 5, 6, 1, 2, 3, 8. I'm shading everything except 7, which is how that came to be. On this one over here, you can't see it, that was a 1. So A is the numbers 1, 2, 4, 5, right there. Intersection means and. B union C complement. That means it's not in B or C. So that's just the 1 and the 8 out here. And then the intersection means what's on the both sides. They both have a 1. So that's the only part I shaded right there. And number 21. So it says that E and F be events in the same sample space. Definitely means I want to draw a picture. This whole thing adds a 1. I can't do anything with E yet because it'll add up to 0.61. F will add up to 0.29. E intersect F is 0.17. So I can put that right in the middle. Then backing up, if F is 0.29, I could do 0.29 minus 0.17 and get 0.12. If E is 0.61, and I already have 0.17 in there, I could do 0.61 minus 0.17 and get 0.44. And if this whole thing adds up to 1, I could do 1 minus those numbers and get 0.27. So then it's saying, find the probability of E complement union F complement. That means I want to add up everything not in E, which is 0.27 plus 0.44, plus I want to add everything not in F. So that would be the 0.44, and I already added the 0.27, and you don't want to add it twice. And we get 0.83. All right, don't forget to do the big review that is on my webpage. Happy studying.